Hey Ramblers! Tonight's video is going to cover Chapter 5.7, which is proving that a quadrilateral is a special quadrilateral. In other words, proving that a four-sided figure is either a rhombus, a rectangle, a square, a kite, or an isosceles trapezoid. Now that's a step further than the previous video on Section 5.6, where we tried to prove that a quadrilateral was a parallelogram. Now we're going to be making frequent and really important reference to that video from Chapter 5.6. So please go back and refamiliarize yourself with it or take a look at your notes that you took. Please take my advice. This is one of the trickiest and most difficult sections in the book. So take careful notes, pause it often, and really make sure that you're following the line of reasoning to proving a quadrilateral is a special quad. Okay, thanks for watching, and I hope this helps. Proving that a quadrilateral is a special quadrilateral can be broken into two big steps. The first involves proving that the quadrilateral, a four-sided figure, is a parallelogram. Because if you can, through one of these five methods, show that the quadrilateral is a parallelogram, it becomes easier to prove that the figure is a rectangle, a rhombus, or square. However, if none of these five things can be established, if none of these five conclusions can be drawn from a figure, then you're not able to prove the quadrilateral is a parallelogram, and you'll have a slightly more difficult time proving that the figure is a rectangle, a rhombus, a square, or a kite, or an isosceles trapezoid. It's not saying it can't be done, but if you can prove something's a parallelogram first, it becomes easier to make some of these other conclusions true. Okay, let's review then real quickly from 5.6. If you can show that both pairs of sides of a quadrilateral are parallel, the figure's got to be a parallelogram. If both pairs of opposite sides are congruent, it's a parallelogram. If one pair of sides are both congruent and parallel, then the figure is a parallelogram. Okay, there are two other ways. If you can show that both pairs of diagonals have bisected the angles, the figure has to be a parallelogram. And finally, if both pairs of opposite angles are congruent, the figure is a parallelogram. All right, so imagine that you have proven that the figure is a parallelogram. Then you'll be over on this left-hand side of my flow chart. And so the steps to proving a rectangle would be this. You'd have to only prove that it was a parallelogram with one right angle, or prove it was a parallelogram with congruent diagonals. If you wanted to prove as a rhombus, after proving it's a parallelogram, then you'd have to show that a pair of consecutive sides were congruent, that's right from the definition, or prove that the diagonal bisects both angles, because that only happens in a parallelogram. That's a rhombus. If you wanted to prove something is a square, after having shown that it was a parallelogram, then you would simply prove that the figure is a rectangle and a rhombus. Okay, let's take a look at what happens if we were not able to prove the figure was a parallelogram. In other words, we couldn't show any of these five methods to be true. Doesn't mean it's not a parallelogram. It simply means we can't prove that it is a parallelogram. Could we still prove it's a rectangle? Yes. You just have to prove that all four angles are right angles. Could you prove that it's a kite? You still could prove it's a kite. Remember, a kite isn't necessarily a parallelogram. So if you show that two disjoint pairs of sides are congruent, you could show that the figure was a kite. Or if you could show that one diagonal was the perpendicular bisector of the other, you could have shown that it's a kite. All right then. To prove a rhombus without having proven that it is a parallelogram first, you would prove that the diagonals are perpendicular bisectors of each other. Now that's different than proving a kite because here you're only showing that one diagonal is the perpendicular bisector of the other. For a rhombus, they both have to be perpendicular bisectors of each other. All right then, that just leaves isosceles trapezoids. Now remember, a trapezoid is never a parallelogram because it has exactly one pair of opposite sides parallel. To prove then that a trapezoid is an isosceles trapezoid, you must first prove that the quadrilateral is a trap, and then prove the non-parallel sides congruent, or prove that the lower or upper base angles are congruent, or finally, you could show that the diagonals of the trapezoid are congruent. Okay, so let's take a moment to review. This is very complicated stuff. But if you know you have a quadrilateral, try to prove that the figure is a parallelogram. If you can, you'll use these methods on the left to show that the figure is a rectangle, or to show that the figure is a rhombus, or to show the figure is a square. If you are unable to prove that the figure is a parallelogram, you can still show it's a rectangle if you can prove all four angles are right. You can prove it's a kite by either of these two methods. You could still prove that the figure was a rhombus even if you hadn't shown it's a parallelogram by showing the diagonals are perp bisectors of each other. And then finally, showing or proving an isosceles trapezoid can be done by these three methods. Again, you can't first show that it's a parallelogram because an isosceles trapezoid is never a parallelogram. Okay, we're going to take a look at using this approach on some of the on one or two of the problems that come up in this section. Please go back, pause, take good notes, and make sure you're clear on how to prove these, because this stuff is very difficult and there's really no other way to do it other than memorization. Okay, hope this helps. Thanks. Okay, let's take a look at how we could apply this method to some of the problems that will come up in this section. Imagine we're given a quadrilateral with this information. What can we prove? What is the most descriptive name that we can give to this figure? Well, let's take it again in steps. So the first thing is, can we prove that it's a parallelogram? We don't know anything about whether the opposite sides are parallel or whether the opposite sides are congruent. But I can tell that both pairs of the diagonals have been bisected. So this figure is clearly going to be a parallelogram. That puts us over on the left-hand side of the flowchart. Now, the steps to proving that it's a rectangle will be to first prove that that I have one right angle. Well, I do have one right angle. Oops. So I can at least prove it's a rectangle. Let's go a little bit further and see if we can prove it's a square. For a square, I'll need to show that the figure is also a rhombus. And to prove that it's a rhombus, after knowing that it's a parallelogram, I would need to show that I had one pair of consecutive sides congruent, which I can't, or that I have to prove that the diagonals both bisect the angles, and I can't do that. So it looks like the best that I can prove is to show that this figure is a rectangle because it's a parallelogram with one right angle, and I can't prove any more to show that it's a square or a rhombus. Okay, let's take a look at another example. Here I'm given another quadrilateral where the diagonals have clearly been bisected and they've been perpendicularly bisected. So by the fourth method, I can clearly show that this figure is a parallelogram. So can I go any further? Can I show that it is a rectangle or a rhombus? Or possibly, if I can do both of those, is it a square? All right, so let's take a look at a rectangle again to remind ourselves what we have to prove in order to show that something's a rectangle. Well, I don't have any information about one right angle. The one here where the diagonals meet isn't really considered a right angle. What they're talking about is that the vertices. Can I show that the diagonals are congruent? Well, in fact, since by the fact that these two tick marks are different, I can assume that the lengths are different, so that the diagonals are definitely not congruent. All right, so that's out, but maybe I can still prove that the figure is a rhombus. Well, in order to show that the figure is a rhombus, I have to prove one pair of consecutive sides congruent. And I'm not given anything about the sides. So what do? Well, the fact that all of these are right angles here in the middle means that I have 4 congruent triangles made up by the bisected diagonals. So by CPCTC, each one of these sides is congruent. Well, that's enough to show that the figure is a rhombus. Now, can I go one step further and show that it's a square? Well, I can't, because you recall that in order to prove a figure is a square, I need to show that it is a rectangle, which I can't, because I was not able to show that the diagonals were congruent. So that's how to make these work, and you just have to go through this process very slowly, and the more you do it, the more you become familiar with it. Okay, thanks for watching, and I hope this helps.